Alright guys, this is Mrs. Lyons, and this video is going to cover a walkthrough on the homework for the covalent compound bonding practice. So, you will need your periodic table for sure when we are doing this, and that's probably all you'll need. Alright, so CF4. So a couple of things, tips. Let's look at these. If you have multiple types of atoms, leave hydrogens for last. First element is usually your central atom. Don't change the number of electron pairs. And arrows should point to where electrons are pairing up. Now, what does that mean? Okay, so let's use this first example. Okay, so we have CF4. So if I look on my periodic table, I will find that carbon has 4 valence electrons. So I would do 1, 2, 3, 4. All right, and then this 4, the subscript tells me I have 4 fluorines. Okay, so I'm going to just put 1 fluorine on each side of my carbon. Okay, and then if I look at my periodic table, fluorine is in group 17, so it has 7 valence electrons. So I'm going to go 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay, now notice what I did. I put all of my unpaired electrons aiming towards that middle atom. Okay, you'll learn to do this as you practice. Okay, and if you do, it makes it easier to kind of follow what's going on. In this example, I'm going to loop the electrons that are going to form a bond. So 1 carbon, 1 electron from the carbon will bond with 1 electron from each fluorine, okay, forming these bonds. Now, as I've said, if you get really good at this and you can do it without drawing the loops and you can just draw the lines, that's fine. But if you do the loops or any arrows, I do want you to get in the habit of drawing a final copy. So I would draw this like this. I would change those pairs that are shared, I would draw them as bonds. And then don't forget to include the unshared pairs around each fluorine. Okay, and then finally, when you're done, you should count how many electrons each atom has to make sure that the octet rule is being obeyed. Okay, so if I look, the bond counts as 2, so 2, 4, 6, 8. That fluorine has 8. And if you look, each fluorine has 8 valence electrons. And then the carbon, if each bond is 2, that's 2, 4, 6, 8. Okay, so that is our Lewis structure for the molecule CF4. All right, let's look at the next one. Sulfur dibromide. Now here you have to figure out what the formula would be. So go back to what you know about names and formulas. Since there's no prefix here, it's just going to be 1S. Di is 2, so it's going to be SBr2. So 1 sulfur, 2 bromine. All right, so if you look at your periodic tables, sulfur is in group 16, so it has 6 valence electrons. 1, 2, 3, 4, 5, 6. And then we have 2 bromines. Bromine is in group 17, so bromine has 7 valence electrons. So I'm going to put 1 bromine on this side, and I'm going to put 1 bromine on this side. Okay, because I know that those unpaired electrons need a partner. Okay, so then bromine, each bromine has 7 valence electrons. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So I'm forming a bond here, and I'm forming a bond here. So if I redraw that, I'm going to draw the sulfur in the middle, attached to a bromine on each side. And don't forget the lone pairs of electrons on the sulfur atom. Okay, again, if you count, bromine has 8 valence electrons and sulfur has 2, 4, 6, 8. So all of our atoms have followed the octet rule. All right, let's do nitrogen trifluoride. So no prefix for nitrogen, so that means it's just one nitrogen. The prefix here is tri, so 3 fluorine, so NF3. All right. So look at your periodic table. Nitrogen is in group 15. So nitrogen has 5 valence electrons, 1, 2, 3, 4, 5. And then we have 3 fluorines. Okay, so again, I'm going to place a fluorine on the sides where I have a solo electron. Okay, fluorine is in group 17, so it has 7 valence electrons. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. All right, and now I'm going to loop the lonely electrons so that they aren't lonely anymore. They're part of a pair. Okay, and then again, this is where I'm going to ask you to redraw this so that you don't show the loops. It just shows the nitrogen bonded to each fluorine. And then don't forget to put your pairs around the fluorine. And then here's one that a lot of people forget. See the lone pair of electrons on the central atom? Okay. Nitrogen has to have that lone pair so that it has 8 electrons in its valence shell. All right, let's flip this over. I think there's 4 more, 5 more. 5 more. It's lots of practice. Okay, so PFH2. Okay, so 1 phosphorus, 1 fluorine, 2 hydrogen. All right. So let's look. Phosphorus is in group 15. So phosphorus has 5 valence electrons. Okay. Then I have 1 fluorine, and I'm going to put my terminal atoms, I'm going to put them by the solo electrons. So I've got 1 fluorine, and then I've got 2 hydrogen. Okay. If I look at my periodic table, hydrogen has 1, it's in group 1, so it has 1 valence electron. Fluorine is in group 17, so it has 7 valence electrons. Okay? And then I'm going to loop, I'm going to pair up the lonely electrons. I like that. You make the lonely electrons part of a pair, and they're not lonely anymore. Oops, I'm out of... There we go. All right. Back to our PFH2. So we're going to redraw this. We're going to neaten it up. So we have a bond to the fluorine, a bond to each hydrogen, and then we've got 7. We've got to add the other 6 electrons around the fluorine, and we have to add the lone pair of electrons on the phosphorus. Now, remember, hydrogen is one of our exceptions. It is satisfied, it is stable if it has just 2 valence electrons. So that bond by the hydrogen is 2 electrons. That makes hydrogen stable, okay? And if you look, fluorine has 8 valence electrons, phosphorus has 2, 4, 6, 8 valence electrons, okay? So every atom in that molecule is satisfied. All right, H2O, water. All right, so H2O, we have 2 hydrogens and an oxygen. Now this is an example where the first element is not the central element. So something that you should remember is that hydrogen is never, I'm going to put it in all caps, never the central atom. And that's because hydrogen can never have more than 1 bond. Okay, so it can't be the central atom. So in water, oxygen is going to be our central atom. And if we look at our periodic table, oxygen is in group 16, so it has 6 valence electrons. 1, 2, 3, 4, 5, 6. And then I'm going to put one hydrogen on each side where I have that solo electron. Hydrogen's in group 1, one valence electron. And then I'm going to loop the lonely electrons, make them a part of a pair. And then I'm going to redraw water like this. All right? All right, let's see. NH2Cl. So, nitrogen. My screen froze. There we go. Okay, NH2Cl. So we're going to start with nitrogen as our central atom. Nitrogen's in group 15, so it has 5 valence electrons. 1, 2, 3, 4, 5. And see why it's so important to draw these Lewis structures for each atom, specifically the way that you've learned to draw them. The reason that I've stressed that so much is because now that we're at bonding, we can easily see where bonds need to be formed. If we were to draw this nitrogen like this, we wouldn't really be able to see where the bonds needed to go. So that's why we stress one electron on each side and then double up. All right, so nitrogen, we have 2 hydrogen. So we have 2 hydrogens, so I'm going to put 1 hydrogen here. Hydrogen has 1 valence electron. I'm going to put 1 hydrogen here with 1 valence electron. And then chlorine is in group 17. So I'm going to put chlorine down here. I didn't leave myself very much room. All right, but my bonds are going to form between the solo electrons, and that's going to give me this as my final Lewis structure. Okay? All right. 2 more. Ooh, and these are names. We have to figure out the formulas. So dinitrogen tetrachloride. So we know that we have nitrogen, and chloride we have chlorine. All right? Di is the prefix for 2. Tetra is for 4. So N2Cl4. All right, now this gives us an interesting situation because we don't exactly have a central atom, okay? Because we've got 2 nitrogens. In all of the other examples, we only had 1 of the central atom. So what we're going to do is we're going to draw this with the nitrogens in the middle. So nitrogen, nitrogen. And nitrogen has 5 valence electrons. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. All right. And then we have 4 chlorines. So now let's think about this. Let's just automatically pair that up because we know that that's going to be kind of the middle of our atom. All right. And if you look, we've got 4 chlorines, which is convenient because we've got 1, 2, 3, 4 solo electrons. So we're going to attach a chlorine to each of those solo electrons. So chlorine, 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 chlorine. Chlorine's in group 17, so it's got 7 valence electrons. And I know this gets a little bit tedious. It's not hard so much as it is just a lot of work. Once you get it, especially. So we're going to loop all those lonely solo electrons so they become part of a bond. Now we're going to redraw this so that it's a little bit neater and we can really see what's going on. So we have nitrogen connected to a nitrogen, and then that nitrogen is connected to a chlorine and a second chlorine. And then this nitrogen is attached to a chlorine and another chlorine. Now, here's something that's important. The order of the molecule, the way the atoms are arranged, matters, but it doesn't matter how you connect things. So, for example, if you would have connected a chlorine, instead of a chlorine here, if you would have connected a chlorine here, that would be fine. Okay, so it matters what elements are attached, but it doesn't necessarily matter. So for example, up here, I could have put the chlorine and the hydrogen could have switched places. They're both always on the central atom, okay? So just keep that in mind. All right, now we need to put in all of our extra, our lone pairs of electrons. So we get 3 lone pairs, or 6 electrons around each chlorine. Okay, and then don't forget, each nitrogen has a lone pair of electrons also. So there is our molecule. And if you count, if you look, do a quick survey, each atom, 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8. All right, each atom has an octet and follows the octet rule. All right, one more. Disulfur dihydride. All right, so that's going to be S2H2. So I'm going to bet this is going to look kind of similar to our example dinitrogen tetrachloride, in that there's 2 sulfurs that are going to be in the middle. All right, so sulfur, I'm going to have 2 sulfurs. All right, sulfur has 6 valence electrons, so 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, 6. And then I've got 2 hydrogens. So I'm going to just automatically link these 2 sulfur, and then I'm going to put a hydrogen. Remember, hydrogen only has 1 valence electron. I'm going to put 1 hydrogen next to each sulfur so I can pair up those solo electrons. So when we redraw this, we have sulfur bonded to sulfur, bonded to hydrogen, and then there are 2 lone pairs on each sulfur. Now, I'm just going to draw this a different way just to show you that you could do it this way. All right, so let's say when you were drawing this, you lined it up so that the hydrogens were out here on the ends. These 2 are equal, okay? As long as there's a hydrogen attached to each sulfur and the sulfurs each have their 2 lone pairs of electrons, your molecule is going to be correct, okay? So you may draw it a little bit differently than me, but what I'm always going to look at is to see how the atoms are connected. What is connected to the sulfur? And if it's a little bit different because you put your hydrogens attached to the sulfur but in a different place, that's okay. All right, so I think, yep, that is it for today. I hope this helps, and I will see you in class. Take care of yourself.